everyone, welcome to my YouTube channel. So here today we are going to be looking at a part of dynamics. So we are going to look at these three questions for this video. So let's begin. So before we answer the question, we need to understand what the free body diagram is. So the free body diagram is FBD, which is our free, then B is for body, then we have D is for diagram. So the free body diagram is a diagram that shows the forces acting on an object as if it is isolated. So basically that is what a free body diagram is. Now, when drawing a free body diagram, you might draw something. Remember, it is a drawing of a single object showing the external forces acting on it. Now, a free body diagram might be represented. For some lecturers, they want you to show a dot, or you can use a box, of which in our case we are going to be using a box. So now let's begin with our first question. So remember, this system is to be considered as if it is isolated. So it is just going to show us the forces. So if you haven't watched the first video on the introduction to dynamics, just watch that so that if there is any concept that you need, you can catch up from there. So let's begin now answering the questions. So we have this question. Figure 4.1 shows the arrangement of an Atwood machine where two objects of unequal masses, M1 is equal to 300 and M2 is equal to 600, are hung vertically over a frictionless pulley. So remember, it is frictionless pulley and of negligible mass. So this is the first part of dynamics. So these conditions have to be met. The pulley has to be frictionless, and also we have to have negligible mass. So now we have been told that the device is used in the laboratory to measure the free fall acceleration. The system is released from rest. Then we are told find the distance traveled by the first block in the first 2 seconds. So how are you going to answer this? So to answer this, what we are going to simply do is that if we have this type of a situation, remember, we are going to first come up with our free body diagram, but we are told that calculate the distance traveled by the first block in the first 2 seconds. So now, to calculate the distance, we need to know the acceleration. So remember, we have formulas. We have formulas from kinematics, which is v squared is equal to u squared plus our 2as. We have our s is equal to ut plus our half at squared. Then we also have our v is equal to u plus our at, like that. So as you can see, all the formulas for you to find the distance, this is our distance s, this is our distance s, they all require acceleration. So first you are going to find the acceleration, then you are going to find whatever your displacement moved is. So the expected answer is equal to a 6.5 meters. So let us answer. First, let's find the acceleration. So remember, we have to draw our free body diagram. So for the diagram that looks like this, so this is the rough diagram. Then we have our M1 there. We have our M1 like that. This is our M2. So now we have to come up with our free body diagram. Now remember what we said, free body diagram will look as if the body is isolated. So we are going to write our force of our M1. So this is our M1 like that. Then what we are going to do is that as long as you have a string attached, so if you recall from the previous video, the force that a rope or a string or anything that is like a cable exerts is called the tension. So now wherever the rope is going, that's where your force or your tension force will be. So this will be up there, it will be tension. So this is how we draw the free body diagram. You show the tension there, then already this wants to go down because gravity is the force that pulls objects downwards. So this one will be our M1G. So this is the weight. In other words, this is just the weight. So the weight is equal to M1G. Mg is equal to the weight. So in this case, it will be our M1G like that. So now, according to the direction that we have been taught, the object goes up like that. So it means to say what we are going to do is that we are going to make whatever is going up to be positive. So we have to more like we have to create a coordinate axis. So a coordinate axis simply tells you what are you going to be considering to be positive or what are you going to be considering to be negative like that. So what we are going to have is that our free body diagram, we are going to take that since it is going up, we are going to say that whatever is going up is going to be considered to be positive y. Then from here we are going to use Newton's second law, which is the summation of forces. In this case, it is the forces in the y direction, since this is just moving up or down, should be equal to the resultant force. In other words, it's just force is equal to ma. So this is the formula, but according to Newton's second law, as long as you add the forces, this is where the summation is coming from. The summation of forces is equal to mass times our acceleration. Then what we are going to have is that we are going to say, since tension is more like going up, it is in support of our coordinate axis, we are going to begin with tension to make it positive. So we are going to say, since one is going up, the tension is going up, the weight is going down, we are going to say our tension, which is our positive tension, minus, since this one is going in the other direction, the weight, which is our M1G, should be equal to our M1A in this case, since we are looking at the mass number 1 like that. So this means to say we have come up with the equation for that. So remember, a free body diagram is isolated, so meaning to say when we are looking at the other case, we are going to consider it to be isolated. Let's just move this to our right. Okay, so the free body diagram for M2, which is our M2 is this one. So we are going to isolate our M2 like that and do something like this. So since the rope is this side, that force will be our tension there. Then downwards, there will be a force of gravity acting on it, which we are going to call the mass of this, which is our M2G like that. So in other words, it is just the weight like that. Also, looking at the situation whereby if already, just by using our logic, if this side it is going up, automatically this side it shall be going down like that. So this is our system. So already you are just going to accommodate this type of an arrangement by saying that the forces are taking the coordinate axis to say whatever is going down for this system, it shall be considered to be positive like that. So remember here it was so you just use your logic. Now the way it is, if you don't know the direction of movement of the system, it simply means to say whatever acceleration you will find, let's say you put this as how it is moving, then the acceleration you get is a negative value. That only tells you to say in the actual sense it was moving the other way around, but the acceleration for it to be negative, it means to say you have reversed the direction, which is no problem. So now we are going to be looking at this one, considering downwards to be positive. So using Newton's second law, we are going to say summation of forces in the y for this one shall be equal to the MA, which in this case will be our M2A like that. So beginning with a positive one, which is our M2G, so we are going to say M2G minus our other force, which is in the other direction, is our tension. So we are going to say minus the tension should be equal to our M2A like that. So when you have these two equations, what you're going to do is you are going to solve them simultaneously. So solving simultaneously, you are going to get your M2G minus the tension should be equal to M2A. Then for this other one, it will be tension minus our M1G should be equal to our M1A, like that. Then what we are going to get is that our tension, this one is positive, this one is negative. Then as long as you have that, as long as you have different signs and the same coefficient, that is 1 1 there, you can just add them. So that means to say this one and this one will cancel. Then we are going to remain with, if you add the two equations, we are going to remain with our M2G. Then we are adding it with, here it is saying minus, so we have our minus M1G should be equal to, we have our, so we are add it with this, so we have our M2A plus our M1A. So it doesn't matter whether you put this equation on top, it will still be the same answer. So from here, what we can do is that we are going to just factorize the G. So G is common. What we are remaining with is our M2. If we remove a G minus our M1, then we have should be equal to, even here A is common, so we have our A, open brackets, we have M2, then we have plus our M1, like that. Then what we are going to get is, we are going to divide our M2 plus our M1 over our M2 plus our M1, like that. Then what we are going to get is that this and this cancels, so our acceleration is equal to our G M2 minus our M1. Then we have over our M2 plus our M1. If you want, you can begin with your M1 plus M2. It is still the same, M1 plus our M2, like that. So this is still the same. So you should know how to solve questions generally in this form, where you are just going to have letters. Sometimes they might ask you without replacing. So from here, we are going to find our acceleration. So our acceleration in this case should be equal to, so we are going to get an acceleration should be equal to, our G is equal to 9.8 times our M2. Our M2, we are told that it is equal to 600 grams. So we are just going to say 600 grams. We divide this to convert it to kg, just divide by 1000 grams. You do that, which is going to give you a 0.6 kg. That means to say M1 will be equal to 0.3 kg. Doing the same approach, just divide by 1000. So we are going to get our 0.6, like that, kg minus our 0.3 kg, like that. Then what we are going to get is over, we have our M1 is 0.3 kg plus our 0.6 plus 0.3 kg. So what we are going to get is acceleration is equal to, so we are going to get a 9.8, like that. Then times we have our 0.6 minus our 0.3. When we subtract them, we are going to get a 0.3. Then we divide this by 0.6 plus 0.3. This will give us a 0.9, like that. So we are going to have our acceleration is equal to, we have a 9.8 times 0.3. This is going to give us a 2.94. We divide this value by 0.9. Our acceleration shall be equal to, divided by our 0.9, it shall be equal to 3.27 meters per second squared. So if we have been asked to find the acceleration, that's the value for that one. Then what we are going to do from here is that, upon knowing our acceleration, we have been told that they want distance. Now we can use any of the kinematic equations to find the distance. So S is equal to ut plus half at squared. We have v squared is equal to u squared. These have got displacement plus 2as, but we don't know the final speed. So we are going to just use this one to find the distance. So S should be equal to ut plus our half at squared. Now remember, it started from rest according to what we have been told. Shows the arrangement of an Atwood machine where two masses of an equal mass are hung vertically over a frictionless pulley of negligible mass. The device sometimes is used to measure free fall. The system is released from rest, so it started from rest, meaning to say the initial velocity is 0. So we have 0 times our time, which is equal to, so our time value is equal to, we have been told the first 2 seconds, so we are going to put our times 2 plus our half. Acceleration is equal to 3.27 meters per second squared, times we are going to multiply the time, which is our 2 squared, like that. So we are going to get our s is equal to, this times this is 0, so we can forget about this. So we have our half, then we have times our 3.27 meters per second squared, then we have times our 2 squared, this will be equal to 4 second squared. But anyways, the units are not even important because you squared this, so the second will square, so that this and this cancels because this is the same as over. So when we multiply this, we can have a value. So let's multiply this times 0.5, then times 4. So the value that I'm getting is a 6.53 meters. So that means to say your distance moved is correct according to the answer that has been provided. They won't provide answers for you, and sometimes they won't even provide the direction of movement. You can just set the direction. If it gives you a negative acceleration, it simply tells you to say the direction is reversed. So now we have found that for our second part, we have been told to find the tension in the string. So the tension in the string, if you have one string passing over a pulley, the tension is the same. If this is T1, this is also T1, like that. So whatever tension you have on this side is the same as the tension that is there on the other side. So that is how tension works. So to find the tension, we are going to have get any of the two equations which you found. So you can get, if you want, you can get this one. If you want, you can get this one to find the tension. So in this case, let's just personal opinion, let me get this one, but if you get this other one, you will still get the same answer. So let's get this. So our tension in this case shall be equal to, we have our M1A, so taking this value the other side, it will be plus our M1G, like that. So the tension shall be equal to, what is our M1? So the mass number 1 is equal to 0.3 kg, if you remember, times our acceleration is found to be 3.27 meters per second squared. Then we add this. Due to space, I won't be putting units so that we have enough. So we have plus our M1 is equal to 0.3 kg times our 9.8 newtons per kg. So what we are going to have is we have tension should be equal to, if we multiply 0.3 times 3.27, we are going to get a value of 0.981 newtons, plus we have a 0.3 times 9.8. This is going to give us a 2.94 newtons. So we are going to get, if we multiply, remember this is the force, MA is the force, mg is the force, that's why I'm saying newton. So we are going to have plus our 0.981, this is going to give us a value of 3.921, like that. So this is our tension. Let's see the expected answer. So we have a 3.9 newtons, so that is correct. Let's look at our last part of this problem. It says that the force exerted by the clamp on the pulley. So the force exerted by the clamp on the pulley. So if you look at how it is, the pulley is this one. Now we want the force exerted on it. So we have here, this is the point of attachments, like that. So remember, according to Newton's third law, for every action there is an equal but opposite reaction. So according to this, if we were to draw our free body diagram, there are two forces as if it is isolated. So there are two forces. There is one that is keeping the pulley in place. That is more like the force exerted on the clamp. Then there are the two tensions. Remember, the tension will be pulling in the opposite direction. So if the string is more like going this side, this is where the tension will be applied. So the tension here was found to be 3.92. Then we have also the tension here is the same 3.92. So remember, for this system not to be moving up or down, it is stationary. It means to say the upward force must be equal to the downward force. So to find the force exerted by the clamp on the pulley, we are going to say the force exerted. Where should I write? Okay, so the force exerted, then we have minus the downwards force, because the force exerted is pulling up, time minus the downwards force, downward force should be equal to 0, because for us we don't want, or this system is, the pulley is stationary, it is locked in its position, it's not moving up or down. So it's not like it is, so it is not moving up or down like that. So as a result, since it is just stationary at one point, it means to say the upward and the downward force must be equal to 0. So the force exerted minus the downwards force, which is this tension, but it is on two sides, so we can say minus the tension plus the tension on one side should be equal to 0. So what we have is that the force exerted should be equal to, we have minus our tension is 3.92 plus 3.92, this is equal to 0. So our force exerted will be equal to a value minus our plus, so we are going to get something like 7.84, like that, should be equal to 0. We take this value the other side, it means to say the force exerted should be equal to positive 7.84, like that. So newtons. Let's look at this one. So we have the coefficient of static friction between the block of 2 kg and the table in figure 4.11 is mu s. Mu s is equal to, we have 0.2. What should be the maximum value of m so that the block does not move? Take g to be equal to 10 meters per second. The string and the pulley are light and smooth. So for this one, we have been given mu s. Immediately they give you mu s, just not to say it's not moving. So it's 0.2, like that. So we have this type of a system. So remember, sometimes many cases they won't even give you, they might give you the downward force, or they might just give you the weight. That's how come we have 20 newtons there. So now we are going to isolate this into a free body diagram. So let's call this one as our mass 1. Let's call this one as our mass number 2. So for mass number 1, we are going to have something like this. It's on a table like that. So we are going to have our mass number 1. So we have the tension trying to pull this side. So this is our tension like that. Then already if there is a force that is trying to more like cause the box to move in this direction, that's our tension like that. So now already remember how we defined friction in the previous video. Friction is the force that causes resistance between two bodies in contact. So if there is a rope trying to pull this direction, it means to say the friction will be acting in the opposite direction like that. So this will be our friction like that. So this is our friction. This is how we come up with a free body diagram in case they haven't drawn for you. Then already we have, this is a box, meaning to say it exerts a gravitational force downwards like that. So we are going to call this one the weight. So the weight, it shall be equal to m1g. So this is the free body diagram for m1. We can say for m1 like that. Then since this box is not more like entering inside like that, since it is not moving inside or outside, it means to say the forces must be balanced. So it's not entering inside, but it's just fixed at one position. It means to say some forces have to be balanced. So what we are going to do is that since there is a downward force, there must be an upward force to cancel this downward force. So this force is the normal force like that. Then what we are going to have is that so we have the normal force, we have the weight of the object like that, we have the tension, we have the friction. From here we are going to come up with our summation. So let's begin with our forces acting in the y direction shall be equal to, now remember it's not going up or down, meaning to say the acceleration is 0, therefore you shall equate it to 0. But if it was entering inside, it could have been ma. So we have our forces in the y is equal to, we have the normal force, so taking upwards to be positive, we are going to have our normal force minus the one that is pushing downwards is the weight, which is our m1g, should be equal to 0. Then we are going to say the normal force is equal to, we take this value the other side, it shall be equal to m1g like that. Then from there, on this same free body diagram, let's look at the forces in the x. So we are going to say the summation of forces in the x is equal to 0. If it was moving, we could have said ma, but we are told what must be the maximum value of m so that the block does not move, meaning to say the acceleration should be equal to 0. So we are going to say the forces acting in the x are, so we have the tension, let's take these sides to be positive where the tension is, so we can have something like this as our coordinate axis, positive y, positive x. So we are going to have something like our forces in the x, so the tension is this side, so we are going to begin with our positive tension minus whatever is pulling it back, in this case it's frictional force, should be equal to 0. So do not forget, if it was moving, it could have been equal to m1a like that. So this is what we have. Now what have we been asked? The maximum weight of that. So now remember, this is just one string, so the string is just one and it's only passing on one pulley system. So that means to say the tension in here is the same as the tension there. So let's come up with our free body diagram for m2. So we are going to say our free body diagram for our m2. So these are part of the max. You draw the free body diagram. So we have our m2 is looking like this. Then it experiences a downward force which is equal to the weight. The weight is equal to our m2g like that. Then we have the upward force like that. So we have the upward force like that. This upward force is the tension. So wherever the string is, so is the tension. So we are going to say the summation, in this case it is only in the y, summation of forces in the y is equal to 0. It's not moving. So we are going to say, let's take, so now here just be strategic. If you took this side to be positive, just take downwards to be positive, so that it's more like it's continuing. You're assuming as if the possibility is that it would move this side then come down that side. So just follow the coordinate axis. quite alright. It might give you the same answer if you don't consider this, but it's very risky, especially if it's equal to 0. If it's not equal to 0, it easily comes out. So in this case, just continue the coordinate axis like that. So we are going to say downwards, the one that is in support of this coordinate axis is our M2G. So we are going to say our M2G minus, then we have the upward force, which is our tension, should be equal to 0 like that. So this is what we have. Then what we are going to do is that we are going to now calculate the weight. So now the frictional force, let's first eliminate the frictional force. According to what we learned, frictional force in the previous video is equal to the coefficient of whatever it is. In this case, it's not moving, times the normal force. So we have the frictional force is equal to mu s. Then we have the normal force is equal to m1g. So we are going to say m1g like that. Then what we are going to do is that we are going to say the tension. So we are going to say, if that's the case, the frictional force is equal to this. So this equation becomes tension minus the mu s. Then we have our m1g like that. Should be equal to, we have a 0. Then this other equation is saying this. So we are going to solve them simultaneously, put them side by side. It will be a t minus mu s, m1g should be equal to 0. Then we also have our m2g minus our tension should be equal to 0 as well. So we are going to cancel this one, cancel this one. Then we are going to have our m2g. Then we are just adding them up. Then we have this one is minus, so we are going to say minus mu s. Then we have our m1g like that, should be equal to 0. Just begin with a positive. If you want, you could begin with a negative. You are just adding up. You can say negative mu s, m1g, then we have a plus m2g, but it's still the same because addition is commutative like that. So we are going to have something like that. Then all we have to do is that we are just going to find now the weight. So we are going to have, which one is this? Our m2. So our m2 in this case, our m2 is the one that is unknown. So let's just take this the other side. So it will be our m2g should be equal to mu s. Then we have our m1g like that. So we are going to have, we divide by g, we divide by g. So it's good to be dealing with this because it will help you in such a way that sometimes they might ask you to say solve the problem generally, meaning to say you show these over. So this is what we have. So we are going to multiply our mu s is equal to 0.2 times our m1. Our m1 is equal to, we have m1 is equal to 2 kg. So we are going to say 2 kg like that. So when we multiply this, we are going to get a 0.2 times 2. This is going to give us a 0.4 kg like that. So this is our m2. That is the maximum. That's the maximum in that case, which is the expected answer. Let's look at our last problem. So our question 3 says 3 blocks of mass 4 kg, 8 kg and 7 kg are connected as shown in the figure below. The coefficient of kinetic friction between 8 kg and the table is 0.2. Determine number 1, the acceleration and the of the system and the tension in each chord. So the chord, which is this cable. So now, as you can see, this tension shall only be the same at this point. If let's say this is our T2, even here it will be T2. So we have a pulley system. So the only tension that is the same is the one that passes at the same pulley system like that. So we have, if this is our T2, let's call this one, let's say here it is our T1 like that. This one is our T2. So here we are going to have three free body diagrams. which we are going to get something like this. So we are going to have our free body diagram for M1. Let's call this one as our M1. So we are going to have something like this. So this is the 4kg one, like that. So we are going to have the 4kg one. Upwards, it's experiencing a tension because it's connected to a string like that. So this is our tension like that. So this is our tension 1, not 2. So if that is 1, even here it's 1 because it's passing through the same pulley system. So we have our tension 1 like that. Then downwards it's experiencing the weight, which is our M1 G like that, since this is our mass number 1, which is equal to a 4 kg. So this is our free body diagram for M1 like that. Let me just move the M1 so that I have enough space. So this is my M1 like that. Then by logic, we can tell that this is 7 kg, this is 4 kg. Meaning to say, this one, which is heavier, it shall be going in the direction where it's heavier, so it shall be going down like that. Then this other side, it shall be going up. So we are going to come up with our free body diagram in that way. So now, just in case the direction is wrong, if your acceleration comes out to be negative, then it means to say that just the direction was wrong, but the answer is still correct because it has a negative. So now, what we are going to say is that for our M1, we are going to say that we are going to take upwards to be positive. Since here it's going down, it means to say up there it will be going up. So we are going to say upwards. In this case, due to space, let's put it here. Upwards shall be considered to be our positive y like that. Then the one that is positive is tension, which is our T1 there. We are going to say summation of forces. This is purely in the y direction. Summation of forces in the y is equal to, it is moving. So we have been provided with the coefficient of kinetic friction, and this is only found if an object is moving. So we are going to have something like our M1A like that. Remember what we were doing. So in this case, the one that is positive is the tension. So tension positive minus, we have our M1G should be equal to M1A. So we have just written that. So this is it for that free body diagram. Let's look at our middle part. We are going to have our free body diagram for our M2. So for our M2, we have this one, the 8 kg mass. So it's looking like something like this. So this is our M2. So our M2 is connected by 2 strings like that. So we can have something like this. So we have our T1, which is this part. Then we have, so this is our T1. Then we have our T2 is on this other side. So we have our T2 like that. It is like that. Then, since that is how we are saying that this will be moving, we are going to be more like be able to say, since here it is going up, if it is going up this side, it should be going this direction. So we are just going to consider for this free body diagram, we are going to consider this side to be positive x. So remember, it is not going up or down, it is just going along this straight line. It's not crossing this line. So therefore, the summation of forces in the y is equal to 0. So let's begin with our summation of forces in the y direction, which is equal to 0. Remember what we had, it's not enter. So in this situation, this block is not more like entering inside and coming out like that. So that's why the summation of forces in the y is equal to 0. Then what we are going to do is that we know that the one that is upwards is the normal force. Then the one that is downwards is the weight. In this case, this mass, we are just going to call it mass. So we have our mg. So we are going to say the one that is going to be made positive, let's just make the normal force. So we are going to have the Fn minus the weight of the object, which is our mg, should be equal to a 0. So the force, the normal force is equal to our mg if it is taken the other side. So we have found that much. Then let's just find the difference. So remember, we are saying that this direction is positive, meaning to say we are going to begin with the tension number 2, since it is the one that is pulling this in this direction. This one is pulling, the tension is pulling in this other direction. So we are going to say for our forces in the x direction, remember it is moving in the, meaning to say it will have acceleration. So we are going to say our m1a like that. We are going to say ma, since the mass is for the middle part, and this mass we are just going to call it m, then this will be our m2. So what we are going to have from there is that the one that is in support, remember, is the tension number 2. So we are going to say T2 minus our T1 should be equal to, we are just not going to say minus T1, another minus our frictional force. So remember, there is friction. So if the object is moving in this direction, friction will be acting in the opposite direction like that. So this will be our frictional force. Let me just use a different color. So as we can see, friction will be acting in this direction as well, because the object is moving in this direction. So friction will be opposing the motion. So that's why we subtract the friction as well. So when we subtract, this should be equal to, we have our ma, since that's the mass there. So we have our T2 minus our T1 should minus our frictional force is equal to our ma. Let's substitute what our frictional force is equal to. So remember, frictional force is equivalent to the coefficient of kinetic friction times the normal force, depending on which coefficient is working. So the frictional force is equal to mu k. Then remember, our normal force, we have found it to be equal to, we have our mg. So we are going to say our mg like that. So what we are going to have is that, let's just replace where F is. So we are going to have our tension number 2 minus our tension number 1. Then we have minus our frictional force, in this case is our mu k mg, which is equal to, we have our ma like that. So we are going to get our ma like that. So we have come up with two free body diagrams. So we are going to have, so for this one, let's just lift this equation. So let's just distinguish them. So for this one, it is our tension 1. So not just tension, it's tension number 1. So here we are going to have tension number 1. So already we have the tension here, we have the tension here. So we can make the tension the subject of a formula, but we are going to do that when we also find the free body diagram for the other. So this one is dealing with tension 1. Let's also come up with another equation that is dealing with our tension 2. So our tension 2 will be gotten from this side. So we are going to draw this one as a free body diagram. So we are going to have something like this, the 7 kg like that. Then upwards there is a tension number 2, which we labeled as number 2. Downwards it shall experience a force. So this mass we shall call it m2g like that. So this is what we have. Now what we are going to do is that we have, it is going down, so we are going to take downwards to be positive. So we are going to say our begin, so the summation of forces in the y direction should be equal to, we have it's moving, so it will be m2a, whatever mass you are dealing with. So this is what we have. So it's moving generally. So we are going to begin with our mass number 2. So we have mass 2g minus, it is the one that is going down, minus T2 should be equal to m2a like that. So after doing that, what we are going to do is that we have now three equations. Let me just lift them. So this is what we have. Now, as you can see, we have T1 here, we have T1, we have T2, so we have a number of things. So you can do this in two ways. Either you can be able to add these two equations so that this and this cancels, and add these two equations, this and this cancels, or you can just make each of them the subject of the formula, which is easier. So for this one, making T1 the subject of a formula, T1 will be equal to, you get this value, you take it there. So we have our M1A plus our M1G like that. Then you are going to take this side so that it becomes positive. So we have our M2G, then this one shall be taken this other side, which will give us our minus our M2A should be equal to, we have a tension number 2. So that means to say you can write the tension number 2 is equal to M2G minus M2A. I've just rewritten the equation. T1 is equal to M1A plus our M1G. So this is what we have, and the main equation is that we have, so get T1, put it there, also get T2, put it there. So that is what we are going to do. So T2 is equal to M2G. So where there is T2, you are going to say your M2G minus your M2A. Then we have, so that's our T2, we have used it here. You have minus, then our, where there's T1, you're going to put whatever is here, which is our M1A plus our M1G, which should be equal to, not equal to, but minus, we have, let's move it a bit, our mu K mg should be equal to our ma, like that. So what we are going to have is that, let's find the acceleration. So we are going to say m2g minus our m2a, then we have minus our m1a, negative times positive, it's minus our m1g, then we have minus mu k, our mg should be equal to, we have our ma, like that. So since our a is this side, all the coefficients, all the terms that have got a, let them be moved to the other side. So this is going to be something like this. So we are going to remain with our m2g, then we have minus our m1g, then we have this one minus our mu k mg, which should be equal to, we have our ma this side, this crosses the equal sign, we are going to have plus our m1a, this crosses the equal sign, it shall be plus our m2a, like that. So this is going to give us, so the common term here is a. If we factorize a, we are going to remain with this m plus our m1, so the remaining plus our m1 plus the other remaining is our m2, like that. Then this side we are remaining with, if we want, we can just factorize the g to make it easy, but it will always come out even if you don't. So we have a g like that, open brackets, you are going to remain with your m2 minus your m1, then we have minus our mu k times m, like that. So to make a the subject of the formula, divide this term throughout. So we have m plus our m1 plus our m2, then we have over our m plus m1 plus our m2. So we are just dividing throughout, so this and this cancels. So our a can be written as this, which is our g, open brackets, m2 minus m1 minus mu k m, then we have over our mass plus our mass 1 plus our mass number 2, like that. So this is what we have. All we have to do now is substitute. So we are going to have something like this. So we have our a is equal to, gravity is 9.8, like that, then times our mass number 2, according to what we have. Mass number 2, if you recall, it is equal to 7, this is equal to 4. So let's just memorize that. So we have a 7 kg minus the mass number 1 is equal to 4 kg. Then we have mu k, the coefficient is given as 0.2. Then we have times the mass of the middle part, which is equal to 8 kg, like that. We have over, we add the masses. So mass, that one is 8 kg plus the mass number 1 is 4 kg plus the mass number 2 is equal to 7 kg. So we are going to have A is equal to 9.8. Then we are going to have our 7 minus 4 minus, we are going to have a 1.6, like that. Then we have over 8 plus 4 is 12 plus 7 is equal to a 19, like that. So A is equal to, if we subtract this, we have 7 minus 4 minus 1.6. This is going to give us, we have 9.8 times 1.4. Then we divide this by 19. Our A value is equal to, so we have 9.8 times 1.4 is giving us a 13.72 divided by 19. This A is equal to, so divide by 19 is going to give us a value of 0.7221 meters per second squared. So this is how we find the acceleration. Now all we have to do is find the tension in the codes. So let's get any of the two equations except the main one, which is having both. So we are going to have something like this. So remember, we have these formulas made subject to the formula. Let's just lift them up. When we lift them up, we are going to get a tension number 1 should be equal to, we have, what is our mass number 1? So our mass number 1 is equivalent to, if you recall, we found the mass number 1 to be 4 kg, or rather that's the one that we have been given. Mass number 1 is 4 kg. Then the acceleration is equal to, so to make this easier, it's okay if you can substitute direct, but let's just factorize. So we have m1 is common, then we are going to remain with our A plus our G, like that. Even here, our m2 is similar, so we are going to have m2 open brackets, our g2 minus A should be equal to tension number 2 to make our calculation easy. So T1 is equal to, we have a 4 kg times the acceleration is equivalent to, we have found it to be 0.722. Then we have plus 9.8, like that. So this is going to give us, tension is the force. So we are going to have 4 times whatever we are going to get, 7.22, 0.7.22 plus 9.8. This is going to give us a value that is equivalent to 42.09 newtons or 42.1 newtons. Then for tension number 2, we are going to get a value of, so we are going to have our M2. Our M2 in this case is equivalent to, it was the one that was equivalent to 8 kg. Then our gravity 9.8 minus our 0.722. Then we have, should be equal to T2. So you can write to T2, space has run out for me. So we have 9.8 minus 0.722. This is going to give us that times 7. This is going to give us a 63.55. So we have 63.55 newtons, which should be equal to tension number 2. So we have found tension 1, tension 2 for that system. We have our tension 1, which was equal to our 42.1, our tension 2, which is equal to 63.55. Then we also have the acceleration with which it is moving is found to be 0.722. So this question, if it was to come, it will carry a lot of marks. Thank you very much for watching. Hope you would like, subscribe, and share for more. You cannot afford to miss out on this very extremely effective lessons. See you in the next tutorial.